Hello and welcome to another Coding Specs Python tutorial episode. Today, as the title of the video suggests, we will be speaking about identity. Now, of course, we all have our own identity, and in fact, this is a topic which is often spoken about in social life today. However, I'm sure many of you didn't know that identity also applies to coding. In fact, our variables have their own identity as well. We can show this by using a practical example and writing a equals, let's say, 1, 2, 3. So a simple list containing 3 elements, 1, 2, and 3. Then we can say b equals the same again. And finally, we can say that c equals a. Now, if we write a is b, we will get false. Now, why is that? Because if I write A equals B, then it says true. So how does that work? Now, this works because each of our variables, in this case A, B, and C, each have their own identity, their passport of sorts. In this case, it is represented by the location that these variables have within the computer's memory. If we say, for example, ID of A, this gives us the location in digits of where that variable, the variable A, is stored within our computer's memory. If we then say the same for B, we can see that it gives us a different value. Now that is why A is B gives us false, because what the identity operator does is it doesn't compare the content of the variable, whereas instead it compares the memory location of that variable. So of course, as I'm sure you can all guess, if I say A is C, it gives us true. Why? Because here in line number 3, we've said that C is equal to A. And specifically, this means not only from a content point of view, but also from a memory location point of view. Which means when I call the variable C, my computer will go and read the same identical point within its hard drive as if it were reading the variable A. We can prove this by saying that ID of C is, as you can see, identical to ID of A. Of course, we also have negative identity operators where we can say A is not B. And in this case, of course, it will say is true. The meaning of this is quite straightforward and is basically the opposite of the identity operator. We've seen what identity operators can do, and so we can move on to the second topic of today, which is membership. Of course, we all love to be members of something, be it a club, be it a society, or a political party, or indeed just a simple group of friends. And of course, so does our code. Our code also has membership operations. And we can show this, of course, by another example and write var, short for variable, and we can call it coding specs. Then we can say that A is capital S, B is PEC, C is, for example, in, and D is capital DI. Now, earlier on, we used the identity operator, which uses the is command. Similarly, the membership operator uses the in command. So we can say A in var, and this, of course, says true. Then we can again say B in var, also true. C in var, true again, of course. And finally, D in VAR, and that's false. Now hang on. Why do you think that the variable d is not a member or is not in the variable VAR? Now I'll give you a moment to think about it, and in the meantime, make sure to subscribe to the channel so you don't miss any future videos. Do you have any ideas? Well, of course, because the variable d has a capital D inside it. So, although the letters DI do appear within coding specs, the D is actually a lowercase d, and therefore the membership operator, which is our in, will check to make sure that in this case D is precisely contained within our VAR variable. So of course, D contains capital DI, and capital D is not contained within our variable. Of course, we can also say, for example, DN in VAR, and that will also give us false. Why? Because we have coding specs, and therefore we have the string DIN within coding specs, not DN. So as you can see here, because the I is missing, our membership operator says false. It's not contained within coding specs. This of course works with strings, as you can see, but also works with lists and other variables. We can give a quick example using lists and say VAR again equals, for example, 1, 2, 3, and 4. Then we say A equals 2, B equals 1, C equals A minus B, and D equals, for example, A divided by 2. There you go. If we say A in VAR, we get that it's true. Why? Because our list contains the number 2. Similarly, we can say B in VAR, B in VAR, and of course it also gives us true. Then we can say C in VAR, and that also gives us true. Why? Because 2 minus 1 is 1, and therefore the number 1 is also included in VAR. Finally, we can say D in VAR, and this is also true. Why? Well, if we print D, we can see that this is actually a floating point number, whereas our list contained only integers. Well, in this case, when we're speaking about numbers, our membership operator is a little bit more lenient, let's say, and allows us to compare different types of variables between each other. So it doesn't matter whether it's in binary, hexadecimal, floating point, either 32-bit or 64-bit, or indeed an integer number, it will always compare the two, and if they're the same value, it will return true. In this case, it's compared a floating point number 1.0 with an integer number 1, and it said that of course it's contained within our list. Now with that, and with this spirit of inclusivity, I hope you enjoyed today's video. Of course, I look forward to seeing you all again for the next episode, and in the meantime, don't forget to like, share and subscribe. I'll leave a link in the top of the screen to my previous tutorials, as well as my coding challenges should you want to put your skills to the test. Thank you all for watching, and until next time, happy coding!